In this episode of Mrs. Fluegel Presents, we're going to talk about magnetism. I think that most of us, at one point or another in our lives, have played with magnetism. Magnetism is an important part of our lives. We use magnets to hang things on metal objects. But did you know that we use magnets in a lot of areas every single day? For example, we use magnets in speakers. We use magnets to drive the motor in vacuums. There are magnets in our credit cards. And MRI machines are just one giant magnet. That giant magnet helps us to visualize all of the tissues and bones in our bodies so we can see if something's wrong. So what exactly is magnetism? Magnetism refers to the properties and interactions of magnets in which there's a force of attraction or repulsion between like or unlike poles. Attraction? Repulsion? What are we talking about here? Well, we're not talking about people. So all magnets have a north pole and a south pole, just like this magnet on the bottom. Wait, North Pole and South Poles? Like the Earth? Actually, yes. The Earth is a giant magnet. So when we're talking about repulsion and attraction, we're actually talking about those magnets. Okay, those magnets, if we have a North Pole and a South Pole that are facing each other, they're actually going to attract each other because opposites attract. However, if we turn one of those magnets around and we have, say, a North Pole and a North Pole that are facing each other, they actually are going to repel each other because likes repel. And if we flipped both of those magnets around so that South poles were facing South poles, they would still repel each other because likes still repel. So, how do we determine the strength between magnets? Well, the strength of force between two magnets depends on the distance between them. The closer that two magnets are, the more attraction or repulsion they'll have. Magnets have what's called a magnetic field around them, where they exert a force on other magnets and objects made of magnetic materials. You can see the magnetic field around this magnet. If magnets have magnetic fields and Earth is a magnet, does it have a magnetic field? Actually, it does. Here is a picture of what Earth's magnetic field looks like. And things like northern lights are actually because of that magnetic field. Now that we know a little bit more about magnets' properties, let's learn a little bit more about the magnets themselves. Like, what kinds of materials are magnetic? Actually, only a few metals, such as iron, cobalt, and nickel. These metals are attracted to magnets or can be made into permanent magnets. However, in order for a metal to become a magnet, it needs to have magnetic domains, which are groups of atoms with aligned magnetic poles. You can see in this picture below of no magnetic domain that the poles of those atoms are facing all different directions. In the next picture, you'll see a magnetic domain where all of those atoms have their poles with the north facing one direction and the south facing another direction. So sometimes we can use magnets to line up magnetic domains in other objects like paper clips. And those paper clips then become magnetic and attract other paper clips. But if I were to take that paper clip off, it wouldn't be magnetic anymore. So, how do we make magnets permanent? Permanent magnets are made by placing magnetic material in a strong magnetic field, forcing those magnet domains to line up. And because it's so strong, those magnetic domains stay that way. So let's go back to Earth one last time. You see, Earth's core is made from iron and nickel, those metals that we talked about being magnetic, and that's what helps create our magnetic fields. The convection currents in the center of our core actually move around and help to dictate that magnetic field. So the next time that you see northern lights, just think we're standing on a great big magnet. I hope that you've enjoyed this video. Please watch my other videos if you have more questions about science topics.